So I want to welcome all of you who are here in person and the people who are on by streaming video. This is the 34th Yale Career Panel, and this is on a candid view of artificial intelligence. So I'm Peter Young. I'm a Yale Branford class of 74, and I would like to welcome you all to this series. This started in 2012, and this is the 34th one. And we have another series, which is Yale Career Fireside Chats on career issues like, how do you join boards or how do you make major career changes and so forth. So the other thing I want to mention is that almost all of them have been recorded. And if you want to watch all but the first three, just go to yalecareerpanels.com, and there's a listing of all the different recordings and professions, and you can choose them. And it's not Hollywood quality, but it's a great way to learn whether it's about government service or drama and film or architecture, and so forth. I want to start out though by thanking my co-organizers who are here. Trish Takemoto, who actually she and I started this initially, and also Julie Sohn, and they worked very hard in assembling this panel, and more importantly, getting the hard cider and snacks for the network, for the session afterwards. So why did we start this? We started because basically I think we came to a realization that as smart as Yale students are and alumni, that there's one thing that really the school doesn't provide, but also society doesn't provide necessarily, and that is really a real-world understanding of different professions. And many professions are very distorted because they're TV shows about being a doctor or a lawyer, and it's unrealistic. And a good example is Bones and NCIS, where you have all these high-tech touch screens and all these other things that's very glamorous. But if you go to the New York Police Department, and go to their forensic science part, I got to tell you, it just isn't the same. So the whole idea is to try to get panelists in individual professions who can give you really a balanced view of what's not just bad, but good and bad about the profession. The last thing I want to say, though, is that there's one thing that we can't do, which you really need to do before any of this matters, and that is to know yourself. Because it doesn't matter if you have perfect information about what it's to be a lawyer or an AI scientist and so forth, if you don't know yourself and have a realistic understanding about yourself, what you're good at, what you're bad at, what you like and don't like. So I would encourage all of you to try to do that and get a good friend who's willing to be honest and help you understand yourself, because it's really the match between your likes, dislikes, and skills and professions that are key. And I remember I was pre-med and probably would have been a good doctor, but I talked to a doctor. He said, I know you. There's no way that you will be in med school and only become a doctor and start having income at 36 years old. It's just not you. And it was a correct observation. So I just encourage all of you, whatever mechanism possible, to try to get a good idea about yourself and self-assessment, right? So I want to start out and just introduce the topic. At first, I won't read everyone's bios because they're in your invitation. We won't use the entire hour talking about everyone's bio. So my far right is Amin Dalla, who's a Vice President, AI Express and MasterCard. To my immediate right, and then to my far right is Hanoi Han Trakul, who is an AI resident with Google Brain. He's a Yale bachelor's. Amin is a MBA from SOM. By the way, we want to thank MasterCard and his company because we needed a room large enough to handle everyone, and he volunteered to host. So we want to thank you. So don't trash the facilities, right? And then to my immediate left is Sanjay Patel. He's the CEO of Data Nautics. He is a Yale MBA, SOM, and he's proved that actually you can be in artificial intelligence and not 25 or 26 years old,
Yep,
right?
absolutely.
Right, exactly right. And the last is David Rosenberg, who's a data scientist in the Office of the Chief Technology Officer at Bloomberg, and he's a Yale bachelor's degree. So we have all Yaleys here. So what I'd like to do is just start out and just briefly ask everyone just take 1 minute and just describe what you do in AI. Okay, and we can just start from here, move to the left.
Sure. So Google Brain is the research and dev wing of Google. And in Google Brain, we do fundamental and applied machine learning research in a variety of topics, from health to speech synthesis to image recognition to video recognition. And within Google Brain, I'm part of a team called Magenta. And Magenta's goal is to explore the role of machine learning and artificial intelligence in the creative process. So how we can use machine learning to synthesize new kinds of musical instruments, like take a cat and take a flute, put it together, you get a cat flute. New ways of composing music. So if you've, on Bach's birthday, you might have seen the very fun Google Doodle where you could put in your own melody, and we had a machine learning system that harmonized your melody as part of Bach's birthday. That's some of the work that came from a colleague in the Magenta team. Her name's Anna Han, but that's some of the work that comes out of the Magenta team. I specifically work on audio synthesis.
Hi, I lead the product called AI Express globally at MasterCard. And what AI Express is, we actually go to MasterCard's customers, banks, merchants, and we look at developing AI models for them within a short span of time. And within this particular group, we are focused on different range of problems, as you can imagine, from a customer experience perspective or operational efficiency, which banks or merchants have to deal with. And I think a key component is, we look at developing those models in quick time, and then a great focus is also in terms of how we actually go about deploying them. So that's and my role is more from a product/business perspective, where I collaborate with data scientists, with policy teams, so that we can actually take the engagement right from ideation through to execution.
Yeah, and by the way, people don't think of AI when they think of MasterCard, but it's amazing the things that are being done. Sanjay?
Our company develops solutions, to put it in a very simple way, we almost read people's minds. Right? Now, if you could, any of you that have customers, right, the first thing you're trying to figure out is, what the heck's on my customer's mind? And if you could read their minds, you would immediately know what to do. We as humans can't do that yet, but the next best thing you can do literally is to ask people what's on your mind. You're buying this from me, tell me what it was like. And if you got that stuff in open-ended content, just free-form text, what would you do with it? Right? And that's what our company does. We kind of read, we built an AI engine that literally reads, synthesizes, and forms all in one package that makes it easy for you to make choices, decisions, etc.
David?
Sure. So Bloomberg's main product besides the news is this thing called the Professional Terminal, which provides information to financial people in finance. And it has, like Google, a search bar type interface or command line interface. So one of the main things I'm working on is search and autocomplete, which you all know from Google or any search engine. You type in what you want, and it starts guessing what you want to do. I also work on research related to extracting information from documents that companies produce, because the big thing Bloomberg does is gather information, get it out of difficult to use formats into easy to use formats. So kind of automatically getting data out of tables and that sort of thing. I also run an internal machine learning education program at Bloomberg, and I teach in the master's program at NYU, the machine learning class. So I have some education connections too.
Now we're going to deviate from our normal pattern. Usually we would then you saw the list of questions right in the invitation. And we're going to deviate a little bit by consensus here, which is, unlike a lot of other professions, all of which have a lot of variety and diversity, right? AI is a lot more diverse, right? There's so many different parts of AI. And I don't think we're going to give you a great definition of every segment, but I've asked each of these panelists to really describe what they think are some of the major buckets of AI, right? Because some things are dramatically, robotics very different from, what you don't do robotics, so they can be very different. So maybe we'll start the other way around and just take a minute or two and just sort of say, what are some of the main buckets that you see that they can sort of try to figure out whether they fit with, right?
Sure. So I guess the classic artificial intelligence problems are the problems that people find easy to solve, but no one ever found an easy way for computers to solve. And artificial intelligence is addressing those problems. So I think computer vision and driving cars and speaking and understanding. I come from a statistics background, actually, and I think there's a pretty smooth continuum of techniques from like the neural networks that drive a lot of the most popular AI things these days through to just how do you analyze data and understand what's going on and tell a story, which is kind of more the domain of classical statistics. And kind of in the middle is this big area of machine learning, which is about predicting the future, predicting an outcome without really providing an explanation. That's which kind of statistics, machine learning, AI, I see them as all very close together, and data science is kind of maybe the umbrella term for all of these things.
Sanjay? Tough question.
It is a tough question. I'll go back to a story. So I was studying artificial intelligence 30-some years ago. My PhD advisor calls me in and he says, Sanjay, you want to do this? Are you sure? I said, yeah. And he says, okay, it's going to take you 8 years to do a PhD. And at the end of it all, you're going to study sociology and psychology and human behavior. Oh, and by the way, you're going to study computer science and mathematics and statistics. So that's really, when you think about AI, it's a whole bunch of things, right? And I think the thing that's interesting about AI today, and this almost touches on kind of like Google Brain stuff, right? What we're finding is as AI becomes more prevalent, it's really just algorithms. It's processes in this order to draw this conclusion in a repeated manner. Our company is pretty simple. I started as a consulting company. We were helping clients all over the world do consumer insights. We'd read a bunch of open-ended stuff. We'd code it into columns. Little did I know when I started this 15 years ago that what we were doing was creating a database that would be used to train a machine learning, to be able to do the same stuff on its own without human intervention, looking intelligent. Right? The first time the system was developed, my team came back and showed me this screen, and it had words like shrimp, lobster, crab, steak grouped together. And I was like, okay.
That sounds like a nice grouping to me.
Yeah. And so my reaction was, so what? Right? They came back and they said, we didn't tell the machine these were similar terms. The machine concluded these were used in a similar way, and therefore they must be related. Our machine, Anna, had no idea that steak is a food item, or fish is a food item, or crab is a food item. She just read and she concluded. Right? She did what humans do. Any one of us in this room can read anything and be able to draw some conclusions from it. And that's kind of where it's becoming interesting. He touched on something interesting, which was the idea of explainability. I think that's where the crux of what we do that may be different than some of the others on the panel, is our clients don't trust the system we built without the system being able to explain why it concluded what it did. Because they're making decisions that spend money, they're putting their careers on the line. And I think that when you're thinking about careers in AI, there's a lot of opportunities that go beyond just the coding or the hard statistician type stuff, which is more of the pragmatic business reality of, how am I going to choose to make this conclusion something I share with my boss and we make a decision.
By the way, I'll interrupt, but it's going through me. And if you Google, I encourage you to Google, or sorry, I don't want to plug Google, but AI. You get some very, very interesting descriptions of AI. And I'm just going to read one or two comments. First of all, apparently this fellow named John McCarthy first coined the term artificial intelligence in 1956 when a group of researchers got together and were trying to figure it out. But if you look at the modern dictionary definition, AI is usually called a subfield of computer science and how machines can imitate human intelligence, being human-like rather than becoming human. So that's, if you look it up in the dictionary, but it also goes on to say that there's lots of different subsegments, and it may relate to human intelligence, visual perception, speech recognition, decision-making and translation between languages. So it says then you have lots of different segments, underneath. So, sure.
So the areas which which I'm focused on is more in terms of machine learning, where they're kind of running data through models so that they can more accurately predict outcomes, as compared to what has been done previously. The kind of use cases we kind of focus on are pretty much those which we're looking at large scale. And going back to Sanjay's point, it's also critical as you kind of go ahead and deploy to have the explainability which goes behind it as well. So, for example, taking the case of fraud, any transaction which actually happens anywhere in the world, comes back as code, as AI applied on it. And as you can imagine, it's something which needs to be explained as well. So that's an area wherein we're seeing a lot of potential, and we find that banks as well as merchants are looking to then extend the benefits of AI starting off from fraud into other areas as well.
Cool. So you guys have heard that machine learning and AI can ingest data in a multitude of domains, ranging from language to financial data. The particular sub-area that I'm very interested in is how all of these relate to sound in its largest sense. So machine learning is changing the way that we, for example, synthesize speech. So how many of you guys have used some kind of assistant that you talk to? That speech that's being synthesized in the case of Google Assistant is being synthesized from a machine learning model that has learned from many millions of hours of human speech what constitutes human speech. In the musical domain, we're now able to, by analyzing a large data set of, for example, Bach chorales or different kinds of musics from a variety of different genres, from pop to jazz, and have the machine learning model figure out what are the relationships between these musical notes and these sequences of musical notes. And machine learning models can now, generate pretty good sounding jazz music. We have some of that on the Magenta blog. And also, machine learning is also being used, for example, in ultrasound for medical diagnosis, and yeah, so that's like one of the other fields. So it's a machine learning can be basically used in a variety of different mediums, whether that's images, videos, sound, financial data to language, and sort of come up with useful answers.
I'm going to chime in for 1 second. There's an excellent book out there that if any of you haven't read it, you should. It's called Automate This. You guys read it? It's a phenomenal read in terms of intelligence and how you can automate a lot of that. So go read it, because it touches on the stuff that I was just talking about.
Now we're going to shift to our more traditional questions, and the first one has to do with what does the future look like in the profession. And it's been interesting when people talk about law. There's some parts of law that are dying, and others that are growing very rapidly, and that's true. Pretty much every profession has that. So I'd like to. The normal question is, where's the profession heading, good and bad? I'd like to change it and just say, what are the areas of AI, and each person maybe list 2 or 3, where there's particularly great opportunity professionally in terms of growth, and what are the areas where 1 or 2 where maybe things aren't going so well, because AI doesn't solve all problems, right? So we'll start up, David. Any comments?
I think so much of you're talking about opportunities in AI, where to put your
AI
efforts.
type of job, professions, right?
I think a lot of it comes down to what you're coming in with background-wise and what level you want to enter at. I mean, one thing that's developing ongoing in AI is there's kind of problems that used to be difficult that are now very easy, and you can download solutions. For example, to look at a picture and tell you what objects are in the picture, and find the objects in pictures, find faces, identify faces, understand spoken voice and translate it into words. All these things that used to be very difficult are now not perfectly, but fairly well solved by technology that's out there. And so, there's room for people who are maybe mostly software engineers to get enough knowledge of basic machine learning to kind of piece together these existing tools. And so maybe you're an amazing coder and you know how to use basic machine learning, but you're not in a position to invent entirely new models. Okay, that would be a type of opportunity that's out there. From a totally different direction, if you want to be a real specialist and you have kind of advanced training or you want to invest in that, there's a lot of things about kind of classical statistical questions, but now machine learning folks are engaging with them more seriously. Questions of causality. What if I may be able to...
You're talking about tasks within AI.
Yeah.
I'm talking about professions with AI, right? You see what I mean? So you're answering like a lawyer, certain tasks like just looking up rules is dead. And no, I'm really talking about what professions. So pretend you're in that the Graduate, the film, where in the end the guy says plastics, right? Yeah, whatever. So if you say pretend you have a son or a daughter, and they say, tell me what is the place to be, but I want to be IA. What's the hot area, or what are things that are maybe a dead end? Which there's dead end in everything, including there's computer science. There's some serious dead ends in computer science, for example. Right?
You should see how the others answer this.
Okay, go ahead.
Actually, I can
Go ahead.
I can elaborate on. I think David brought up a really good point about sort of the difference. Talking about a traditional software engineer, piecing together existing systems. So I'm speaking as someone who basically just went through the job search market, like literally just like a year or two ago. So this is still very fresh in my mind in terms of what kinds of positions are out there and what are sort of the opportunities and how companies, word these opportunities. But the way that I see it is that a lot of these AI jobs that exist right now in 2019, especially if you're starting out in early career like me, basically sit on a spectrum. And on one side of the spectrum, you have almost like pure research, developing new groundbreaking ways of doing machine learning. And this is a lot of these jobs are what are called like research scientist roles. Essentially, many people in research scientist roles will have a PhD in statistics or physics or computer science, and their main job is to come up with these breakthrough models that sort of change the way that we do, voice synthesis or image recognition. On the other end of the spectrum, you have your software engineering roles that have been dominant for the last 10, 20 years. The traditional SWE roles that you might have already heard of. When you take coding camps and hack lab boot camps to learn coding skills, these are the skills that are in that particular side of the spectrum. And then in the middle, you have what are called like research engineers, who are roles that require you to have a knowledge of both cutting-edge machine learning and have some kind of statistical or mathematical background, but are also able to implement a lot of these like a software engineer does. And so when you're sort of thinking about where you want to be, it's thinking a lot about where on the spectrum you are, because the skill sets and the kind of background that you have will have
Are very, very different.
are very, very different. A research scientist is expected, so for example, I don't have a PhD yet, so I could never apply for a research scientist role because I could try, but
We can always do that.
This is only speaking on the technical spectrum. AI also touches a lot of other legal questions, which we might be talking about later. So around this technical spectrum, you also have opportunities in other domains like law.
And I think we should emphasize the fact that people tend to think, well, you've got to be a computer scientist. But maybe a good example of why that's not true is Yale had a touring set of they had a program where, and they had it here in New York in Lincoln Center on artificial intelligence. And they had 3 professors on the stage, but they weren't 3 computer scientists. They had one person who's a computer scientist from the robotics lab. They had one person who was a psychologist, right? Another person who was on neuroscience. And the 3 of them said they worked together to deal with AI problems. And, and clearly 2 out of the 3 weren't programmers, right, and so forth. So it emphasizes the fact that actually it's much broader than just, what a lot of people think.
I think that's a really good point, because if you think about AI, right, you got to think about how it's not just you're going to build a model, but you got to build a model. It's got to be deployed in an environment, and it's got to meet the legal, norms and laws which are applicable for that company. So if you look at it, it's almost like first the models have got to be developed. And Hanoi touched about, hey, what are the spectrum of roles within us? There's R&D, then coming on to like more basic modeling, so there's that particular aspect, right? So that's the data scientist roles and potentially some data visualization roles as well. Coming on to the second aspect, we have more like, like product management or business related roles, where you kind of own, let's say, you may be owning a product which is heavily driven by AI models. So that's one aspect. On the other hand, for example, Google search or whatever the product is, on the other hand, you could also be having, maybe like consulting programs where you're kind of going to other customers and kind of building models for them. So in that particular product/business role, you're kind of developing the roadmap. You're trying to see as to, work collaboratively with the data scientists, with deployment, and you're kind of responsible for the revenue of that particular product as such. So it's more like a classical product management. Yeah, and then the third and fourth areas, I mean, to me is okay. Now that models have been built, they've got to be deployed in the environment, and it's got to be performing at scale. You can't be like going in, and waiting for systems to respond. They got to respond like in milliseconds. So that's that particular aspect where it's kind of related to software engineering, but more from a deployment perspective. And then lastly, which is more related to like policy-related aspects, wherein hey, are the models which you're building, are we kind of using the data which you're allowed to use? Are they within acceptable guidelines? So that's the whole policy-related areas which are also like quickly evolving. So, I mean, if you look at AI, I mean, maybe like at first glance it's like more like the data scientist roles, but then it's broader than that, because at the end of the day, it's got to be consumed at large scale, which means that you have to go through all these different continuum functions.
Well, that's true in a lot of industries, right? You say the auto industry, it's not just people who design autos, it's a whole ecosystem, right, that's required, which has lots of different parts.
I'm going to take a slightly different view than the other three, because these guys are really kind of hardcore in the algorithms, in the analysis, and in the modeling. I'm an entrepreneur, and I make money by selling stuff that people want to buy that solves a problem for them. Right? And I'll give you a story about vitamins versus painkillers. In the startup world, they basically tell you, are you selling a vitamin or are you selling a painkiller? For me to convince you to buy a vitamin, it's really, really hard, right? I've got to convince you of the potential benefits. You're sitting there saying, I can spend this money on that, I can spend it on vitamins. You've got pain, you show up and say, I'm hurting, and I say, here's a $10 tablet, it's going to immediately relieve your pain, you're going to pay the $10. All of us are experts at solving pain in our respective industries, right? And I think when you look at it from that perspective, every single one of our industries is going to be impacted by artificial intelligence. You're going to need all three of these types of people on the back end to create the solutions, right? But you're going to need the people that can identify the pain. These three guys are not working in a box that is not connected to the real world. Perfect example on my side, our clients want to understand what matters to their customers. They've got a whole host of online review data. We just met with the NBA. Through Ticketmaster, they've probably got 250,000 open-ended reviews sitting there that they haven't read. Their pain is, my fans have told me, how do I understand it? In our case, we apply AI, so I have data scientists and programmers and stuff on the back end who were really solving a business problem. And I think that's where the big opportunities, if you're thinking about AI, that's where they are. Right? I'm not an AI programmer, data scientist, machine learning expert. I'm a person that understands consumers and understands how to create consumer insight. And we've been able to build a business on AI. So every single one of you, whether you want to be impacted by AI or not, you're going to be impacted by AI. And if you're ahead of the curve, you can use all of these new tools and technologies and cool stuff that's coming out in ways that solves real problems in your industries and makes you money. The other thing I will tell you, and this is really fascinating because I've been around a long time, the system we run today and the technology it's built on and the number of people it's taken to do it, just 5 years ago, would have required multi-million-dollar data centers that we can run on Amazon's cloud or on IBM's cloud. Things have become so much cheaper, it's become so much easier to do these AI-based startups that it should really be opening your eyes to saying, how do I solve a pain in my industry because I'm the expert on that? And then how do I find the people to help me code it, which is an easier problem to solve.
But there's another issue, which is the availability of data, because all of AI depends heavily on the existence of the relevant data. And one thing's true is the amount of available data and accurate data is increasing significantly. Because without data, AI is pretty useless, right?
So I think there's two aspects to it. Now I'll touch on both. One is absolutely you have to have high volumes of high quality data that your machine can then develop its predictions on. The second is kind of what I call stupidity, right? Imagine the scenario: a Martian UFO lands here, a guy from Mars pops out. He's looking around and he sees these millions of mouse traps out there with little yellow pieces on them. He has no idea what a mouse is, what a cheese is, what a mousetrap is. He steps out of his spaceship the next day, there's 1 million dead mice. He runs off to Mars and he says, we've got to make these little yellow things because they kill mice. That's what I call stupidity, right? Sometimes when you have large volumes of data, if you're not careful about it, your AI engine really knows nothing. So there's a lot more you have to tell it. You have to teach it that cheese doesn't kill mice. The fact that cheese was present and 1 million mice died doesn't mean if you put 2 million pieces of cheese out there, it's going to work. Right? And it's a combination of those two things.
We're going to switch to question 3. All professions have myths and realities. This is addressed to any of you. What's a myth that is important for people to know about because it would cause them to make the wrong decision, and versus new reality? And each person can pick one at the most, but one that says if you believe that, you might make someone in this audience, or you might make a mistake in making a career decision.
I'll start. A lot of people think they're not smart enough to be in AI, and that's absolutely wrong.
David?
A lot of people think that if you have heaps and heaps of data, there should be something you can do with it. You just hire a data scientist. And that's not always so easy to get useful information out of data. You have to have a plan and an idea.
I think the one thing is that there are roles which go just beyond data scientists, so just to keep your eyes open on that. And it's not just like you're just cranking away data. All these models have got to work in the real world, so there's a lot more to it.
I think there's a myth that our current state of like machine learning and deep learning can solve any task and should be used to solve any task. But there's so many things to do out there that machine learning isn't really designed to do. So if you literally just wanted to like write an app that is like a to-do list, you would never deploy a machine learning system to do something like that. And I think there's a much more careful consideration that has to come in when you want to solve a problem, and machine learning is very well suited for other tasks, but then traditional computer science, much like, I guess, like the way I'm thinking about it is like classical mechanics and quantum mechanics, it's sort of, there are two completely different set of problems that these two fields are designed to handle appropriately.
Similar kind of question, but different way, but career-oriented, which is, want each of you to take a minute and say, for the part of AI that you're in, right, what are the characteristics of people who tend to do well and may or may not be happy? I mean, doing well and being happy may or may not be correlated. I mean, you can do well and be unhappy, right? Or I guess it'd be hard to not do well and be happy. But what kind of, what are sort of the traits of people who tend to do well, accomplish well and happy? And what are the traits where you've noticed people who say, this was the wrong place for them, right? And we'll go from here to here, okay?
Sure. So I'll be speaking from the domain of someone doing like research and development, and researching new AI algorithms, publishing papers in top-tier conferences, and figuring out new ways of doing image recognition. I think that a really important set of skills. Sorry, I forgot the question earlier.
The question is, what are the characteristics of people who, in your profession, who tend to do well and are happy,
Right.
and what kind of people tend to kind of run into wall?
Yeah.
Right?
So a lot of my colleagues in Google Brain, there's a mix of people who have very strong research backgrounds. So they have PhDs, they have masters, or even if they come straight from undergrad, they did a lot of research in undergrad and really enjoyed working in the lab, that working in like a chemistry lab or a biochemistry lab, or they were into helping run psychology experiments. Even if it's not related to machine learning, I think that a lot of people who enjoy the work in Google Brain are those who are really, really excited to do research and really excited to try and develop new ways of solving problems, and are not afraid to basically be stuck when you can't figure out how to solve this new research problem. I think that it has a lot of overlap with the kinds of qualities of people that you meet in master's programs and in PhD programs. And people who
Which is why you got to go back to get your PhD, right?
yes. And people that maybe not do as well or don't enjoy, and I do have some friends and colleagues who have come into data science or have come into machine learning and said, like, no, this is not for me. Are people, for example, who don't like the fact that we can't explain some of these models. It's fundamentally something that really bothers them. So I had a friend, for example, who did machine learning and said, this is not for me. I'm kind of annoyed that we can't explain deep learning models. And also, I think some of my friends who haven't enjoyed it as much is they're not interested in research. They prefer to, for example, work on a team where they're trying to build some kind of new application or some new kind of like web deployed system, and they're just not interested in a new way of synthesizing, voices or a new way of driving cars. It's just not something that interests them.
But there may be jobs in AI where that is true. It's just your part of AI, you have to be willing to do research.
Right. So this is speaking for like someone that would be in research like Google, right?
I think just picking up from there, more from a product side of AI, if you're like product managing, AI services. I think what people who do really well are those who are basically comfortable with ambiguity, because you're going to be facing different kinds of problems. So just being able to relate to that and being able to problem solve, working with the data scientists in your team. So that's very crucial. And if you're not like a good problem solver, or you're just kind of uncomfortable with ambiguity, then you're going to quickly become disillusioned. So that's key. The other aspect is just generally, good collaboration skills from a product side, because that's where, you got to like blend in, all the richness of the models, which, the data scientists will bring alongside, hey, but can these models actually be deployed in production at large scale? And then combining that alongside, hey, does this fit in within the policy guidelines, which, your legal and your privacy counterparts will bring along. So I think high on collaboration, high on problem-solving skills, and I think generally if you have like folks who really enjoy this career are those who really like to learn a lot, and this kind of into new verticals. You quickly get a quick feel for what those critical aspects are for those different verticals, be it healthcare or payments or financial services, and you kind of see some similarities and also some learnings as to what you can transpose onto other verticals as well.
By the way, one common theme, it appears, is that at least the part of AI that you're all working in is a collaborative thing, right? No one's saying, oh, I go off like a professor, that's studying one thing on my own. I do the research and I produce a book 5 years later. I mean, it's clear, unless I'm misunderstanding, that AI is generally a kind of a team collaborative sport. Is that true, or is that the wrong? I mean, that's the sense I get from listening to all four of you. Is that probably true? Yes. Well,
I don't know if it's universal, but it's very common.
Very common.
A team is working on a problem.
Sunday. So for you, same question, right?
Yes, I think what we've tended to find is we're really much more practical AI than research and kind of the deep learning type AI. And a lot of cases we find the people that are unhappiest and have left our company are the ones that are passionate about what they do, really like writing cool algorithms to come up with pretty cool insights. And then the reality that you're hit with when you take it to your client is they say, yeah, but so what, I can't do anything about it. So therefore it's not useful. Right? So it's a tough line when you spend a lot of time kind of building something really cool that's extremely insightful, but it's not actionable. So, that seems to, on our side, be a challenge.
But that's a characteristic if you're a business-oriented project in AI, basically, right? Because you have to solve a problem that somebody paid you to solve.
Yeah.
Right. It solves a problem. David?
Picking up on themes that the others have already mentioned. One is, so in our line of business, it's not so common to be handed a crisply defined problem and asked to please just solve this as well as you can. That's very rare. Much more common is that there's some rough idea about what we want to accomplish. And it's basically part of your job to make that concrete and make it better defined and solve the problem. And then you realize, oh, that wasn't exactly the right problem, and you changed a little bit. This iterative process, the ambiguity that you need to be comfortable with, where you don't know exactly what you're trying to do, but you have to choose a path anyway. And as far as people who enjoy that, it's also, it helps a lot to want to engage in the business goals and care about what you're trying to accomplish from a bigger picture, not just from an AI data science perspective, but why are we doing this? What is the end user, the customer going to care about? And if you like engaging and thinking about those things, you'll probably be much happier on what you're working on.
Now, I'm going to turn to something we normally don't talk about, but it's very, very important on this topic of AI. So this is, usually we just follow these questions. And it's two questions that are very much hot topics about AI. One is, will AI basically destroy everyone's jobs and create a lot of unemployment? And then the other is the ethical issue, right? That there's a lot of discussion about whether AI creates some real ethical issues along a number of issues, whether it's privacy or otherwise. So any one of you, we're not going to do an order, and you don't have to say anything, or you can. But if any of you would like to, talk about either of those two issues, which are, you can't pick up a newspaper without people saying, "Oh, AI is bad" or whatever, right? So anyone.
Well, as you mentioned, the one thing that machine learning AI absolutely needs is data. And so, whereas there might be some jobs being lost, hypothetically, because this AI is solving the problem that humans want to solve. You need humans on the back end kind of teaching the AI how to do it. So demonstrating how to solve the problem. And it's called creating training data for the artificial intelligence. And I don't know if you guys have heard of Amazon Mechanical Turk or Crowdflower. It's these companies that employ huge numbers of people to solve very simple menial tasks that are easy for people to do, not easy for computers to do. And as these people solve these simple tasks, that's giving training data to build up AI. So it's kind of a shift of, there's perhaps a shift of jobs.
Do the people lose their jobs then?
I don't think so. And there's automation, but so some things are being automated, but it kind of creates new possibilities.
And then piggybacking on that, what's interesting is if you're using Mechanical Turk or
Crowdflower,
stuff like that. What becomes interesting is kind of the whole idea of bias. So I'll give you the practical example from our side. We have a ton of training data. However, when you look at traditional surveys that our clients have, and you look at response rates by gender, what you then find is in a data set, 60% of the responses will be from females and 40% will be from males. Now, if you use that data to build algorithms that tell you what you should sell in the future, there's a missing component. You overestimate one thing, you underestimate one thing. Now, that's okay in this data set because we know. The question you have to ask yourself is when you're creating that training data, what inherent biases have you brought to the data? Right? A perfect example is the IQ test that used to be administered decades ago, where a certain set of facial characteristics was viewed as lower IQ. They were essentially mongoloid features. And so that IQ test was biased towards a certain race. And administered in a certain condition, that was okay. That when you extend that same test and you took it to a totally different society, the test became biased. So I think AI's got that issue, which is our training data that we use to teach the algorithms. If that training data is biased, your algorithms are absolutely biased. And you're going to propagate bias. You're just going to do it at a much faster pace and volume.
Well, the other is behaviors are different by society, by country, and so forth. So you build an AI machine that's really good at giving advice, in Alabama, it may not do such a good job in France, right? But because the biases and the thinking is different.
Yeah, just moving, adding on to the bias, I think we spoke about explainability of models a little bit earlier, so I think there's a lot more effort being put in on that side of modeling, and that potentially can address some of the ethics-related areas. But in that particular vein, you find that again, AI solution providers are along the spectrum. There are more established companies which have been focusing in terms of providing the reasoning behind the black box, if you will, in terms of their outputs. So I see a lot more focus happening in terms of explainability from a data science perspective. A lot more emphasis on that to ensure that from an ethics perspective, they are more in line with what is being used here.
I know, AI bad?
Ooh, that's a pretty loaded question.
Well, I'm trying to steer it back to my original question, which is there's a lot of this issue about whether AI is bad, either ethically or in terms of job description.
Yeah, I can quickly address both of those questions. So the first question on is AI replacing jobs. The way that I like to think about it in this conversation is not a new conversation. Are machines going to take our job? This was a conversation that was already being published on the front pages of newspapers during the Industrial Revolution, when steam engines started to take over, traditional jobs that were being done by hand. And then when the electrification came, and things that used to be run by steam engines we could now use electric motors to power a lot of these things. Another wave of jobs were lost and given to those more sort of advanced pieces of machinery. But every time this shift has happened, economics has shown that the number of jobs and the economic growth that comes out of these shifts in technology always outpaces the number of jobs that were lost or replaced during that particular time. And the very optimistic young view is that as AI replaces some of these jobs, that the amount of economic growth that we get from applying machine learning would generate all these growth that could sustain even more of these jobs. I think there's the classic example from a Vox video about when ATM machines were introduced back in the day. Again, this is beyond my era, but back in the day before there were ATMs, there was you had to talk to a cash teller or something, and then they would give you the money. And then apparently the ATMs came along and replaced that, and the cash tellers were very, very scared that ATMs would end their jobs. But it turns out that the number of jobs in that sort of role actually increased because it freed the company and lowered costs for them to distribute all these ATMs and hire people to do other tasks that humans were good at, which is face-to-face contact, bringing on new clients.
But that may not be true within one particular industry. For example, a classic example was when they invented cars and tractors. It essentially wiped out the farmers, right? Because tractors substituted for manual farming. But there weren't a whole bunch of other farm jobs available for those farmers. But then they created jobs in the automotive industry and so forth. But it took a while, and it actually was partly the cause for the Depression was actually not the stock market, but the automation of farms and so forth. But eventually the jobs appeared, they just appeared somewhere else, right?
Mm-hmm. Right, so this brings a really, this is where I think just writing algorithms alone in a research group with your teammates, but not thinking about the other concerns becomes important because, for example, it's important that there are some ways of, for example, retraining so that people can make these transitions to where these jobs have now been taken away and popped up somewhere else. I'm also going to quickly talk about, is AI bad? I think that really, any technology, I like to quote popular culture, but when Thor gets the hammer and he's basically told that you can use a hammer to destroy or to build, but it's in the wielder of Thor's hammer of what's being done with that. I think it's the same thing can be said with machine learning and AI, where if the intention, or for example, if the data has been collected in a severely biased way, for example, that if you're using legal data about incarceration statistics that already systematically through our political and social systems bias against African American communities, and then use that to train a model that decides who gets parole and things like that, that's a very, very clear form of a biased algorithm that will do more harm for society than good. But AI can also be used in very interesting ways to correct for all of these things. For example, thanks to new ways of doing speech recognition and speech synthesis, we have, for example, applications that can be deployed low cost on mobile devices around the world to teach people English and actually, record what they're saying in English and provide feedback in real time on how they can be improving their pronunciation. And I think that that's like really awesome, like a really cool use of some of the speech synthesis technologies.
Yeah, now they have devices you can say something in English and it speaks Chinese to the other person, and they can say Chinese and you can hear it. And sometimes it works and sometimes it doesn't work so well, right? So now what I'd like to do is to make sure that we leave time at the, for questions from all of you. So we've got about 10 minutes left. We're going to take questions from the audience here, but I'm also going to take questions from people who are online. The people who are online, what I'd like to do is just use the chat function that you'll see and type in questions, and I'm able to see it here on my iPad. But let's start with some people here. And again, as I said to the people here, if you have a question, just come up front just so you're closer to the microphone. Does anyone have, okay.
Yeah, sure. First, wanted to thank the panelists for taking time to speak with us. Should I come closer to the
No, just stand right there.
Here?
Okay, go ahead.
So the history of AI is a history of fits and starts. There are some people who believe that we are on the way to another AI winter. I wanted to know, since you have a kind of experience from both the academic side and the industry side, how sympathetic you are to that concern.
And they think there's an an AI winter because?
I guess limitations in where, if you look at adversarial examples that show that we really don't understand what our models are doing, I think explainability is far behind where it needs to be to actually be satisfiable for a lot of customer concerns. It's not clear that the research is there to provide that knowledge. And then it's also unclear if the current models will scale in the same way. So it's just something that I think a lot of people are beginning to see. It was sort of like 2012, deep learning started to become more mainstream. We started throwing compute at that, and now we need more ideas. Basically, I think that's a consensus a lot of people have, or at least a change in some of the fundamental paradigms. So here's some of the founding fathers of AI speak about how we need to rethink, maybe revise gradient descent, rethink a lot of the fundamental paradigms.
Good question. So to anyone,
I'll take a stab at that. I kind of going back to the late 80s, which is when I was studying AI. There was this huge movement towards creating a machine that could tell a joke, because that was going to be the gold standard. If I can tell a joke, I understand the social environment, I understand the context of a lot of things happening. Humor is funny, it's very context sensitive. And this was happening in the late 80s in the research labs, and we were convinced by the early 90s we were going to have joke-telling machines. And it didn't happen. But the industry kind of moved very quickly from this AI bandwagon as an industry, not as research and academia, because that continued kind of along down this path of research, to what at that point were called rules-based systems. So you took a whole bunch of rules and you coded them, you kind of built a decision tree. And that was the idea that was labeled expert systems. It was codable, it was definable, all of that stuff. I think we're at the same point right now. Over the last few years, you've seen the term machine learning creeping in a bit more in the context of AI. And I think machine learning is really nothing more than creating what we as humans have as algorithms in our heads, but letting the machine do it. Because this is curated data created by humans, and the machine creates the same algorithm, maybe a bit faster, then it can process millions of records. Because the data input mechanism is a lot faster than human. So I think you're right. I think pure intelligence, I don't know if it'll ever happen. And I think it's far from happening. I think what we're going to find over the next 10, 20, 30 years is that perhaps humans aren't as intelligent as we think they are. And seriously, go read that book. It's called Automate This. And the idea is a human is a creative person. We write a piece of music. The stuff that Google's generating, it sounds like music to me. Right? So I have no ability to say that was a human generated thing or a machine generated. I do have the ability to say, if somebody tells me it was human generated, that it sounds flat, it doesn't sound like it's got emotion, it doesn't have personality to it. But that's us trying to be smart. So I don't know if intelligence is even out there if all we are is algorithm. So I think you're right, it's going to be another interesting 20, 30 years. Which means there's a huge career opportunity for everybody in this room that wants to be in AI. This stuff's not solved.
AI winter in your
No
life?
way.
No, no,
No,
no,
no winter. No, I mean, AI is solving real problems. It's making real money like right now, and I don't even think that the industry has absorbed the tech that already is established and works. I think the difference from decades ago is that it was a lot of research funding that was over-promising, like translation and real artificial intelligence, telling a joke. I mean, that's still beyond. But now, it's scoped down the problems that we can already solve and we are solving. And so, I mean, it's not to say that every useful machine learning paradigm has been invented. Sure, things are going to change, but I don't think it's going to be a winter.
I think as we speak to from as to where companies are kind of parking their funds with respect to investment, they are looking at investing more in terms of AI and looking at earmarking funds because they get to hear or see about it. So we definitely want to venture and see what's possible out there. So we definitely seeing companies earmarking pools, and that's where the rubber meets the road because you first need to have a budget to go experiment. So that's kind of helping break through the inertia, and there is a good amount of interest which we are seeing from customers as well.
Winter? No?
Sure.
Okay.
I was thinking we should.
Well, we should go to another question, but I also want to react to one thing you said. My personal theory is that in fact, there are different types of problem solving. And you keep talking about rules and algorithms, but a whole lot of problems are solved in non-linear, non-rule ways. You have people who say, they just looked at a whole bunch of data, a lot of things, and found some correlation. They can't explain how they solved it. That's a unique human trait. It's not something that all species can do, and it's almost impossible to teach. The rules thing, you could say, well, if you apply these rules to this problem, you can get this answer. But massive correlation and pattern recognition is not rules-based, and they can't explain. And I think that's one of the hardest parts of AI to figure out, right? Because it's not with algorithms, it's not rules-based, it's massive correlation. And that's going to be interesting because there's part of the human brain that is rules-based problem solving, and there's part that is creative pattern recognition. And that's going to be the toughest one to, I think, solve. Any other questions here? Yes, go ahead, stand up and just stand at the end of the table. Okay, go ahead and speak up.
My name is Olga Kramer. I'm coming from finance backgrounds. It's called FP&A, Finance Planning and Analysis. And I kind of think that within my profession, AI can be, and data science can be heavily used and kind of make my profession sort of disappear in a couple of years, maybe 5 years. It's like budgeting. I work for huge corporations most of my working life. And mainly in oil and gas for the last 7 years. And what you normally do, you actually you understand the one-offs during the year, use the assumptions and sort of extrapolate that for whatever years. Like if it's digging oil project, that's it can be 100 years or whatever, and it's very easy to do sort of And my question is, what do you think, what industry will be heavily impacted by AI if you have this overview? I understand finance about myself. I understand transport because we all know that probably this will be heavily done with the AI. But what else? Where we should expect the replacements of human work?
Before they answer, just from my point, I run investment banks, I understand. All these people who are out there who are brokers, they're just losing their jobs because essentially they're using AI and robo-advisors. So all those people who call from Merrill Lynch and so forth, they're under serious attack in the profession. And I don't know where they go. But you're going to have thousands of these brokers and advisors where a big part of what they do in terms of advising people is going to a computer. So that's a real thing that's happening. And what she's asking anyone here, where you think there's going to be a tipping point on AI affecting the component?
So I'm going to give sort of a different landscape in the medical domain. So machine learning has gotten a lot of success in the medical domain, whether it's from analyzing CT scans or like three-dimensional scans of like people's organs to identify, extremely small tumors that, a doctor, even a team of doctors could never be able to see. In those particular professions, there's an interesting situation that arises, which it's not, are the doctors actually being replaced by some of these algorithms? Actually turns out no, because it's been shown that what's called human in the loop, what we call in research like human in the loop AI, has shown that when humans and machines work together, the outcome is always, in certain domains, always better than if the human was working alone or if the machine was working alone. And a very good example of where that synergy happens is in the medical domain, where they show that if you have doctors trying to identify tumors by themselves and have the algorithm try to identify it by themselves, they do pretty well. But if you put those two forces together, it always outperforms
There's a radiology.
but also in other domains too. There's the retinal pathology, something like that, which is like looking for something in the back of the eye. But I think that there are domains where that are going to be heavily impacted by machine learning, but that there are these situations where it's not that the professionals or the experts are being sort of pushed out outright, but finding these sort of beneficial situations of like human in the loop where it's the combination of the two forces that actually yields like an even better outcome.
Was there another question? Yes, go ahead. Come up so we can hear
I
you.
have sort of like a comment and a question, and kind of a comment, possible suggestion for future panels. Thank you all for your time. I think we learned a lot from your insights. My one question is, I'm curious, I think it would be interesting to have a follow-up panel with the title of 5 professions that could see a significant growth from the rise of AI, or that could be disrupted by the rise of AI. And I think the 5 that I can think of would be the legal profession, the health profession, advertising and marketing, finance and especially hedge funds, and also the design and product development field. So for me, I think it's almost like, based on this discussion, it'd be interesting to have a follow-up discussion with case studies. And my other comment, it's not so much a question, but I don't want to engage in a semantic debate, but I'm almost thinking that AI itself is not really a profession, but it is a discipline that affects and touches upon all the professions that we know of today. So I'm
I think
curious
it's a
why.
valid point, and it's actually very. When we were thinking, actually, when Julie and Tricia and I were thinking about how to title this, it was a challenge, right, Julie, about what would be the right title, because there's so many ways you could put around it. And we finally said, well, everybody says AI, so it's not perfect, but you're absolutely right.
I don't want to engage in semantic debate, but
No,
I'm
no,
thinking
I
about that, and I Googled it before I came on the subway, and so a lot of the taglines were, professions that will be disrupted by AI, or professions that will benefit from AI and machine learning, or that will spike, or that will take, things, jobs that are on the downward trend, and jobs that are on the upward trend due to, advances in this.
Well, that's a good idea, and I encourage everyone here and the people who are online, if you have any thoughts about what panels we should do, and they're in 2 groups. One is careers, and the other is career issues, right? Just send them to yalecareerpanels@gmail.com, and we love to have ideas, because the best ideas are the ones that you guys care about, right? So I would encourage you to do that. Well, we tried very hard to start and end on time. We started on time. We're 3 minutes late, but that's okay. And I want to really thank one of my co-organizers who did a lot of work. And you're going to be the beneficiary of the hired cider and all this other stuff that we've brought with us. But particularly the panelists, who I hope you all agree did a great job. And it's frustrating, right? Because there's so many parts of AI, so we could go on for a couple of hours. Actually, someone said, well, how about a panel of 50 people? We'll cover everything, right? But please join me in thanking our panelists, so I think that's terrific.